Thank you, Dr. Sakata, for the introduction. And I would like to thank Fabio Montosi and the organizing committee for Icomst 2014 for inviting me to present in Uruguay. And this is my first time in Uruguay. And today, I'm going to share the current research trends in strategies to improve brief color and explain the molecular mechanism involved whenever those mechanisms are available in scientific literature. So the global beef industry is a multi-billion-dollar business, close to $250 billion, and the major players are countries in North and South America and Australia and New Zealand. And it involves operations from farm to the fork. So when we go for grocery shopping in a grocery aisle, beef is king, yes. 10 years ago, National Cattlemen's Association did a study. And what they did is they broke up a $100 bill that an average American consumer spends and saw what is the trend. Surely, beef is the top priced commodity that is purchased in a grocery store, and the next one is just half the price, close to half the price, and that's soda. So that means beef is critically important to agriculture community across the world. When we go for grocery shopping, what we do is we look at the color. If it looks good, we'll buy. That's because we cannot taste beef, we cannot touch it, we cannot smell it. If it looks good, we'll buy it. If we are ready to pay regular price, we want the meat to have this color. You wait for 3 days, meat starts to discolor, and it is this point when it becomes slightly brown. Well, that's where we get in America, buy one steak, get one steak free. Now if you're willing to wait for another week, it would be like this. And that's where we get buy one, get three free. And somebody is losing money and industry is taking the cut. So a previous estimate in 2000 has been published that, and it says, on an average, American beef industry loses $1 billion as a result of price discounts due to discoloration. And this is very important because in 2000, the total revenue of American beef industry was 49 billion. Right now it is 79. So this number could have gone higher right now. So the molecular interactions between myoglobin and a multitude of factors within the skeletal muscle contributes to the color change from red to brown, and sometimes from brown to back to red in meat. And the factors that are critically involved are antioxidants, proteome, pro-oxidants, and ligands. And we're going to cover the molecular mechanisms and their applications today. Manipulating beef color has been a major strategy in beef industry. So we can use it pre-harvest or post-harvest, as well as we can manipulate endogenous or exogenous factors. Beef color has twofold application. At the point of sale, we look at this color. If it looks good, we buy. At the point of consumption, we look at the color and tell if it is done or underdone. So cooked color is an indicator that people use for safety, and I can say that that's sometimes often wrong. So we'll see the strategies one by one. With respect to the fresh meat color, one of the aspects that we're going to cover is pre-harvest strategies in color. In pre-harvest strategies, we can manipulate diet, growth promotants, and the management. So we're going to see the latest trends in these three strategies. Well, some of the investigations were not necessarily looking at color, but the findings are quite a valuable feedback to industry as well as researchers. In United States, grain is one of the most prominent costs in beef production. So this previous research done in Montana State University substituted barley in animal diet instead of corn and found that, well, when two different varieties of barley, Chinook and H3, were substituted, it increased the color or red color in the steaks. Well, there was no effect on growth or carcass trait, so there is an added effect of these two varieties on color. Now, why is this happening? It's probably because of the antioxidants inside these two varieties, which are not present in corn. The next one is feeding regime. Well, grain-fed is a major strategy in the United States, whereas grass-fed is prominent strategy in South America as well as in Australia and New Zealand. Now, we have seen that these two feeding regime will affect the consumer acceptability when we taste meat. And now, a study from Argentina almost 5-6 years ago found that this is a direct comparison between grass-fed and grain-fed. And the study found that grass-fed beef had high color stability than grain-fed. And part of the reason is, this is speculation, that vitamin E, which could be high in grass-fed. Now, with the vitamin E in grass-fed animals, I will change gears to vitamin E. A picture is worth 1,000 words. Previous studies by Cameron Fossman in the 80s have clearly shown that vitamin E could stabilize beef color when it is supplemented to animals during finishing stage. And the molecular mechanism is right here. Vitamin E prevents lipid oxidation, which in turn prevents discoloration of oxymyoglobin. So vitamin E has a twofold effect: prevent lipid oxidation and then prevent discoloration. So vitamin E's newer role is in combination with other feedstuff. Well, one of the applications is enriched meat. Ever since the positive effect of PUFA on cardiac health became prominent, a lot of research has been done to enhance the level of PUFAs in beef. One such strategy is to feed flaxseed oil or linseed oil and improve the PUFA content. The downside of this strategy is the PUFAs are highly unstable and they contribute to lipid oxidation as well as color discoloration. So two research investigations undertaken in different parts of the world found that if we manipulate the PUFA content of meat, it is absolutely necessary to address the endogenous antioxidants. And one such endogenous antioxidant which can minimize the discoloration in such cases is vitamin E. And vitamin E has an application now when we manipulate PUFA. Well, if we have pumped gas in the last 10 years, we have seen that the price of petrol is going up and a lot of countries are changing to biofuel. In the United States, a lot of corn, which is traditionally used in animal feed, is diverted to biofuel, and the byproducts of biofuel industry, distillers grain, has immense use in animal feed. But the problem is these byproducts can change the fatty acid profile and thereby compromise the stability of beef. So a previous investigation by Bloomberg et al. Found that to minimize the discoloration, animals could receive 250 to 500 international unit vitamin E per day. And this is relevant in the modern day animal husbandry because I have talked to animal nutrition colleagues. They say that in another 10 years, it will be practically difficult to find a feed regime without distillers grain in the United States or North America. Zilpatrol has been approved as a growth promotant in United States, South Africa, and Mexico, and a lot of studies have evaluated its effect on growth, carcass traits, and tenderness. While several studies found no or little effect on color, this one from Oklahoma State University found that there are something that we need to consider when we feed Zilpatrol. So this study evaluated different duration from 0 to 40 days and in two different types of animal, calf-fed Holsteins and beef steers. And they evaluated the color of gluteus medius in PVC and high ox packaging, and the result was interesting. There was no effect on calf-fed animals, but there was a prominent effect on beef steers in which high ox and 20-day feeding had a positive effect. So what does this say? Well, a lot of farmers and production systems are moving to Zilpatrol, but Zilpatrol is not a silver bullet for color. We got to consider for marketing, animal type, duration, and packaging. And what is the reason behind Zilpatrol having the effect of color? My former PhD student from Brazil, Bruno Costa Lima, this did work in pork, but it's a pretty similar concept in beef. Ractopamine, another beta agonist, increased the expression of glycolytic enzymes in muscle. So glycolytic enzymes, when they're overexpressed, the muscle become glycolytic and have the muscle fiber shift, and glycolytic muscles are obviously more stable in color. Further research is necessary in Zilpatrol area. Consumers want to know where the meat comes from, and organic meat is becoming popular in the United States as well as across the world. So one of the studies done recently has compared conventional and grass-fed, or not grass-fed, organic beef side by side for the color stability. The problem they saw with the organic is that conventional beef had better color stability and organic beef had lower color stability. Now this positions organic farmers with a challenge with appropriate packaging system or antioxidant treatment before they market, because meat is organic but it could discolor at a faster rate and consumer may not buy it from a retail case. This one was an interesting finding from Brazil. Juliana Ziloki Miguel from Brazil did the study, and her study was on Bos indicus animal, which are the most common beef animals in Brazil. So she studied immunocastration as a strategy to improve management, and it was applied in feedlot because it takes effect in a very short duration. So this study came up with some interesting findings which could be applied both in North, South America, and in other parts. So when you look at the darkness, the study found that immunocastrated animals had less darkness compared to their non-castrated animal counterparts. So this could be utilized as a potential strategy for minimizing dark cutters across the world. So dark cutters could compromise retail as well as a consumer perception. So, but the molecular mechanism is still yet to be characterized, but this is a potential strategy in Brazil. Now changing gears to post-harvest. Now, due to shortage of time, I'm going to focus predominantly on 4 major categories of post-harvest strategies: aging, manipulating muscle source, packaging, that is modified atmosphere packaging, and nitrite embedded film, and finally, injection enhancement with TCA metabolites. Well, universally, wet aging is the most common strategy to improve tenderness. Well, the studies have characterized the role of wet aging in improving tenderness, but it can also compromise color because the mechanisms in beef which affect enzyme system and mitochondrial integrity could change during wet aging and can affect color. So classical studies on blooming has been focused on fresh cut beef which was probably aged less than 2 weeks. Now, a study by University of Arkansas Meat Research Group has done blooming time calculation in Longissimus thoracis and gluteus medius in cattle and the carcasses were aged for 35 days, extended aging. Obviously, it improves tenderness, but the effect on blooming was a little different. In Longissimus, there was no effect of blooming during aging. But in gluteus medius, blooming was not good when carcasses or muscle cuts were wet aged for long duration. So extended aging obviously improves flavor, tenderness, but we got to consider the muscle source when we put these cuts into wet aging for long duration. Well, aging has another effect on color stability. So a previous study by Andy King and others from US Meat Animal Research Center has evaluated the color stability of beef from 14-day aged meat and 35. Obviously, they found that 14-day is better for color than 35 days. And a similar finding was from Europe, Vital et al., and they found that up to 21 days aging when they tried, the color stability was pretty low after 10 days. So the take-home message for industry and researchers is that obviously tenderness is improved by wet aging for longer duration, but retail stability of color is not going to be that optimum. So we got to consider optimization of aging time, which could give good tenderness and good color stability. Well, changing gears to muscle specificity. In one of the marvelous study done by Dave McKenna in 2005 from Texas A&M University has characterized the color stability of 19 beef muscles. So the take-home message was, you take any biochemical parameters affecting color. The color labile PM or source major and color labile, color stable LL or longissimus lumborum are at the opposite end of the spectra. You could use these two muscles as an anchor point at the both ends. The rest of the muscles would be in the center or in between. So why is this difference? They come from the same animal. So we investigated the proteome basis. So the sarcoplasmic proteome, which is 30% of the total proteins in meat, is different in these two. That was a hypothesis. So my former graduate student Paulson did this work in profiling the proteome of these two muscles, and he did compare the proteome and color traits and tried to identify biomolecular markers for color. So the idea behind this experiment was, we know what is the role of genome in the muscle and what's the role of genome in the animal's life when it is alive. On the other hand, when the animal is dead, it becomes meat, then genome doesn't have much of the role. Then it happens with the proteome. So the relationship between proteome and quality traits with respect to color is probably not well researched. So we try to understand the relationship between the two sides, this side. So the results were pretty interesting. We did a correlation between the proteins that are highly abundant in LL, which is the color stable muscle, and the color traits. Now here we see that a lot of antioxidants, peroxidoroxin 2 and chaperones, heat shock protein, PMSR, they're all highly abundant in LL, and they are positively correlated to redness, color stability, and methmyoglobin reducing ability in a positive value. So that means these enzymes and proteins will prevent degradation, or prevent denaturation of myoglobin and prevent myoglobin from undergoing changes. So they maintain the color in cherry red stage. So this one shows that the biochemistry of LL and PM are completely different, and we got to come up with the specific strategies to address their stability during retail. Changing gears to ground beef, which is another commodity critical to beef industry in the US. Well, price of ground beef is obviously much lower than steak, but in an average year, US beef industry sells $12 billion worth ground beef. 40% of the fresh beef sold in the United States come from ground beef. Ground beef is prepared from trimming and from tough cuts. So this previous study by Rains et al. From Dr. Melvin Hunt's laboratory in Kansas State did compare different combinations of muscle in ground beef and how they affect color stability. Well, obviously when ground beef become brown, nobody's going to buy. So Chris Rains' study clearly showed that muscle blend influences color. So muscle blends containing more than 50% of high color stability muscle and lower than 25% of low color stability muscle are better for retail. So we can manipulate muscle source in ground beef and thereby make ground beef more attractive to consumers. Subsequent study by Chris Rains evaluated cow type. Mature cows contribute significantly to US beef industry. 1/6 of beef produced in the US are from mature cows, which are typically coming from dairy or beef type cows. Well, Chris evaluated the burger composition, the burgers from two different cow types, dairy and beef. And it was somewhat interesting because dairy type animals had better color, longer color shelf life. So classically, cows has not been paid much attention in terms of beef color stability, but here it says using dairy cows in the meat blends would be better for color stability. Another strategy we have tried is packaging. Now this slide is provided by Dan Siegel from United States. So vacuum packaging in nitride embedded film. The American consumers have not been adjusted to the purplish red color steak in a vacuum package condition. Although vacuum packaging minimizes microbial growth and lipid oxidation, people have not really into the color. So this strategy is coating internal side of the packaging with a soluble sodium nitrite crystals and then vacuum package steaks using this particular package. So what we see is after enough exposure, after 24 hours or so, these sodium nitrites are reduced to nitric oxide, which binds to the surface myoglobin, and it looks cherry red, exactly same as oxymyoglobin. And this has been one of the major areas where we can use vacuum packaging in combination with this nitrate technology. So Jim Klaus and his group from Wisconsin has done a wonderful study on different muscles and different aging time and how they are affected by nitrite embedded film. So I personally spoke to Jim on this technology, and his publication had the take-home message. Well, obviously the reducing ability of these three muscles are different. So reducing ability is critical. Muscle has to reduce nitrite to nitric oxide. So that reducing ability changes during aging and between the muscles. So there is no silver bullet for NEF. We have to consider muscle source and aging. So this slide clearly shows this is the typical vacuum package steak. This is the nitrite embedded film steak. An average consumer prefers this cherry red color, and that will go better. 2008 review by Dr. Ken McMillan has clearly showcased the importance of case ready. More than 2/3 of fresh beef sold in the United States is in a case ready packaging system. A typical meat aisle look like this, no butchers around. People go in, look at the color, buy it. So a lot of studies have been done in packaging systems. So we are focusing on two systems that we have tried, carbon monoxide and high ox. Well, I agree that carbon monoxide is controversial in many other parts, but in the United States it has been approved by FDA in 2004. But prior to that, Norway used it for 2 decades from 1984. And Arvin Sorheim, Björg Eglandsal, and Erik Strulinde has done quite a bit of work in Norway on this area. Now, this picture I pulled up from my PhD dissertation. I prepared some oxymyoglobin and carboxy, 100%. If I switch the label, there is no way we can identify. They are completely indistinguishable for human eyes. And when you look at the spectra are more or less similar, but the ratio of the peaks will make it easy for identifying carbon monoxide treated myoglobin and oxygen treated myoglobin. So when FDA has approved carbon monoxide for US beef retail, Rich Mancini at the University of Connecticut and I did a series of work on using carbon monoxide and different combination of antioxidants on color stability. So the results has shown that there are exceptions and considerations on beef industry. So here we have put the steaks in 3 different packaging systems commonly used across the world: vacuum, high oxygen, and carbon monoxide. After 5 days, color became low, redness became low in a vacuum, and it remained that way. But it increased in carbon monoxide and high ox, but again it dropped in high ox. Whereas in carbon monoxide, it was much high. So carbon monoxide treated steaks are much red and have chances to get consumer attention. Whereas after 9 days, the value decreased for oxygen or high ox packaging system. In the second part, we put 2 steaks, LL and PM, in different packaging systems. Here is where the classical rule, color stable and color labile definition has changed. Here you see that the classical color stable or color labile definition is applicable only when oxygen is there. When oxygen is there, LL had greater redness than PM. Take away oxygen, the change is visible here in vacuum and high ox, in carbon monoxide. In vacuum and carbon monoxide, PM had greater redness than LL. And again here, carbon monoxide map had greater redness than high ox and a vacuum after refrigerated storage. So this shows that there is no silver bullet for packaging for intact steaks. We have to use different packaging for different steaks to increase the color stability. Look at this display case. A traditional or the modern day aisle look like this, but as you look at the packaging, you can see that more than 50% of the space is taken by the gas mixture. Meat is only less than 50%. So again, this investigation by Chris Rains from Kansas State University did evaluate, can we decrease the packaging volume and thereby make sure that we can increase the profitability for industry by decreasing the transportation cost. So Chris evaluated different carbon monoxide concentration that is less than 1% of the total level and different headspace. So this was interesting. This study had this message that we can actually decrease the headspace volume, and at the same time, if you increase carbon monoxide concentration up to 1%, it has the best effect. So that way, we can save the space in a retail case, as well as we can save the space in a truck when it is carried from the packing plant, and thereby increase sustainability. One area where we have focused on our research, and so many others have done this work, is metabolites. US beef industry allows use of lactate as an antimicrobial historically in beef. But now lactate has another role, that is to improve the color. Not only lactate, a lot of TCA metabolites, lactate, pyruvate, succinate, and malate, are known to increase oxidative stability of beef. But their role is primarily through mitochondria. Through mitochondria, these metabolites will enhance regeneration of NADH and thereby increases the color stability by methanoglobin reduction. So beef color stability through lactate addition has been explained clearly by the previous work of Ranjit Ramanathan and Brad Kim, and it needs mitochondria. So how is the effect of lactate when we use different packaging? So this work, again from our previous work in color, has shown that there is no effect in carbon monoxide MAP when we use lactate. There is no effect in vacuum packaging, but there is a prominent effect in high ox. So if we are using lactate, there is no need to use carbon monoxide. High ox is the best one to combine with lactate. Well, I'm going to quickly go through the succinate, malate, and pyruvate. All these things will work great in steaks where functional mitochondria is there. Now, if it is ground beef, mitochondrial integrity is not maintained, so they may have a little different effect, but still they work. So the functional mitochondria is an absolute necessity when we inject meat with succinate, pyruvate, and malate. Another ingredient that we have tried to improve color stability is chitosan. Chitosan is a byproduct from shrimp industry, and it increases the color stability of ground beef in every packaging except vacuum. Vacuum already has a stabilizing effect by decreasing the formation of oxymyoglobin, but these ones are good for chitosan. Changing gears to the last part, cooked color. Cooked color has been widely investigated, especially from the standpoint of doneness and tenderness. And when we cook meat, myoglobin denaturation increases over temperature, and that leads to the change in color. So these two slides, one from Kansas State, another from USDA ARS, shows that myoglobin denaturation goes on high as the temperature goes up. Now, 2 days ago, Dr. Wheeler presented his excellent talk on food safety. We got to consider this in relation to food safety. Now, this defect, premature browning, is not a color problem, it's a safety problem. Premature browning is a condition where myoglobin denatures at a temperature lower than 71, which is the stipulated temperature for cooking beef by USDA. Although we are supposed to cook beef with a thermometer, a survey by National Cattlemen's Beef Association found that only 1 in 6 consumers use thermometers. The rest of us use just color. We look at the color, if it looks brown, we'll pull it off and eat. Now the problem there is that color, cooked color, is dependent on the redox state of myoglobin before cooking. Carboxy and deoxy has greater thermostability compared to oxy and mesh. So a patty with a carboxy and deoxy, when cooked to 65, will look like this, and inside will be like this, whereas in these two will be like this. A consumer is more inclined to pull this off and eat and have a chance of E. coli infection. On the other side, people cook this for a couple of more minutes and make sure that they're brown and thereby enhance the food safety. So any strategy to minimize PMB focused on decreasing the level of methmyoglobin and increasing the level of deoxy and carboxy. So towards the end of my PhD, I did a short work on erythorbate. Well, here we saw erythorbate has an effect in minimizing internal cooked PMB in aerobic packaging, but not in high ox. High oxygen depletes pretty much every antioxidants inside meat. Chitosan. We tried chitosan. Again, there is no effect of high ox. There is no effect of chitosan on high oxygen. And this is interesting because chitosan had effect in high ox in fresh color. And here you see that chitosan had an effect on AP, the huge effect, and had a huge effect on vacuum packaging, and then another huge effect on carbon monoxide. So we looked at, is there any antioxidants that we can try and have an effect on PMB? We came up with succinate. This work published in 2011 shows that succinate is a good antioxidant which can minimize premature browning in high ox. Here we can see this trend which is quite similar to PVC and vacuum packaging. So this work was published in 11, and now we change gears to steaks. Steaks historically had no problem with the PMB, but with the injection enhancement coming in, there is a possibility of E. coli going inside the steak. So these are non-intact steak. They are injected with the injection holes. So we tried different packaging systems in steaks, and we found that the worst color, the worst internal color in terms of browning was in high ox. After 5 days and 9 days, it had the lowest decrease, highest decrease in internal browning. On the other hand, you see that VP and carbon monoxide had very stable internal redness during the storage after 5 day and 9 day. So carbon monoxide and vacuum are pretty good for premature browning, and they work well. In the subsequent study, we pulled up loin steaks, that is Longissimus lumborum. Here, we looked at high oxygen VP and the carbon monoxide again. Now, here we tried 2 different temperatures, that is 66 and 71. 66 is the typical temperature where consumers get confused on the color. So here you look at, there is no difference between 66 and 71 in high oxygen, whereas there is a huge difference in carbon monoxide and vacuum. So an average consumer get confused in high ox. At 66, it looks like 71. So we pull up, and there's a chance of E. coli contamination or survival. On the other hand, there is another color defect, which is in beef also, persistent pinking. Persistent pinking is quite opposite to PMB. This is not a safety concern. This is a quality concern. We want our steaks to have particular doneness. So if the chef makes the steak at a reasonable temperature and you see a rare appearance, whereas you wanted a medium, you're going to send it back to the restaurant kitchen. Now that can cause serious losses to meat industry as well as the retail food service sector. Now this major reason for this persistent pinking is high pH, which could be seen in dark cutters as well as in some cases in grass-fed animals. So the pH effect of pH effect on myoglobin denaturation is given by the previous study from Dr. Hunt's lab. So here you see that as the pH increases, the amount of myoglobin denature decreases. So the meat will stay pinkish red in the interior, and thereby consumers get confused. Is it really cooked or is it just raw? Well, it can affect steaks, and it can affect ground beef, and it can affect different model systems. So how do we decrease this problem in dark cutters. Dark cutters meats are traditionally diverted to food service where we don't see the fresh steak before we cook. So Dr. Jason Apple's lab group in University of Arkansas did a series of studies. What they found is if you inject these dark cutters with lactate, you can actually decrease the pinking. Now that was quite odd for me because I looked at the, before I did the next experiment, I looked at the previous studies. All lactate does is improve the color in fresh meat. How does it decrease in cooked meat? So my current graduate student Mahesh did this model study. What he did is he isolated myoglobin from beef and incubated it with lactate for 2 days, a typical enhancement study, and then cooked it in a model system to 71 degrees C. So after 10 minutes, we started seeing the difference. By 10 minutes, lactate increased myoglobin denaturation. By 15 minutes, again, the same trend. So how does lactate work as a myoglobin denaturation promoter? Well, this effect is primarily due to the salt effect. When you add more salt, it can decrease the stability when you expose the proteins to high temperature. So further work is necessary to examine how this lactate effect in a ground beef. So we haven't gone too far in that area. So just let me wrap up this talk, giving some final thoughts and future perspectives. So we know that a lot of factors can affect color. So what's the future? How do we address the future needs of beef color? Well, I would say that we need to address animal factors, non-animal factors, environment, exogenous, endogenous, so many other things. So in my thoughts, a biosystems approach addressing animal's body and its environment is extremely critical to improve color stability. And that way we can address all the way from animal to the proteome, all the way to the beefsteak. Now, who will do it? Well, I see a lot of new graduate students in this meeting. The future of this research in their hands. So you have a lot of way to go for. And I'm sure that you can do a better job than I have done. And at this point, I would like to thank quite a bit of researchers who helped me prepare this plenary paper and helped me prepare the slides. All these researchers from 3 countries, United States, Brazil, Norway, they interacted with me, and my co-authors, Dr. Melvin Hunt, my graduate student Mahesh Nair, and my colleague, Dr. Greg Renfro. And finally, for American Meat Science Association for providing a wonderful platform for our scientific discussions through the color guidelines revision that happened last year or year before last. So that has been wonderful so that I could know who does what across the world. And at this point, I would like to thank you for your kind attention. Again, thanks to the organizing committee and Fabio, and I would like to take any questions. Thank you.